This is a time we're going to combine on the same package a 32 nanometer Western CPU and a 45 nanometer graphics and chipset. And the question would be, why would you put two of these together? There are many benefits. One, to really talk about turbo. It's all about managing the thermal. Imagine that you could do turbo between the CPU and the graphics, and you could see that sometime one thing is operating at full steam, and the other time the other one is operating at full steam. This is going to give us great opportunities to get the best of the graphics and the best of the CPU. We're going to move on, and on 32 nanometer, we're going to have a second generation TOC. This one we're going to move monolithic. We're going to improve significantly all the parameters you could think about, from CPU to graphics to adding new instructions and to way better manage. And this is an example of the functionality you already see on extremely early material of Sandy Bridge just getting out of our factories into the labs to the debug. So we expect great new cool products coming out from the Intel in the same boring year after year coming out new technologies. This is all to create these extremely fashionable, nice looking devices. But doing silicon and microprocessors is not sufficient to deliver these fashionable, cool looking things. There's a lot of other technologies that are developed in our lab to help our OEM customers and the developers to go do the coolest, nicest looking things. We are doing computational fluid dynamic simulations of the boxes. And it's all about thermals. Muli talked about the fact that you could do turbo. The turbo is very much dependent how good the thermal design of the platform is. The better it is, the better the turbo could get. And you could see over here comparison that we did in our lab. Using the Core i7, we could get at 45 watts to a higher performance we could get on a previous generation quad-core Xeon products just a year or two earlier. There are many other things we do. We reduce the size of the packages, we reduce the power of the devices, went from 45 watts to 35 watts, going to 25 watts. We're going to go from 3 packages to 2 packages when we go to Arrandale, and we're going to have great looking products. It's amazing what you can do when you have an extremely low power microprocessor. This is a Dell Attitude, 16-inch. Used to be the 16-inch high-performance products would be very thick. This is one extremely thin. It has a dual core, Core 2 Duo inside. A very nice design. We are developing concept problems. This is the way we are trying to ignite the innovation of the industry to help you, the developers, come up with nicer, cooler looking devices. The one at the top left is the one I like the most. You know, I like AIG, I have to fly coach. I don't have a private jet. And if you fly, I presume some of you do fly coach, at least the Intel guys. And when you do email, and then the guy in front of you do recline. There are a few things you could do. Either go to sleep, or you type that way, or you have this wonderful device. You bring the screen in and you type below the screen. Wonderful way to increase your productivity. Not too many people know, but if you look at the Business Week article from May 2007, we show the concept that you can design a thin device that was the thinnest notebook ever designed. The industry came later on and, of course, used the technology that we developed. We paved the way for the developers to go bring extremely cool, nice-looking thin devices. And the ideas continue to move on and on. And I'd like to show another concept that we are doing as part of our design. This is a new development that we are doing. It's called Tangent Bay. I don't know why Tangent Bay has to do with it. It has one big screen. You could do whatever you do, either do email, you could see video. You have these wonderful 3 screens at the top. You could have your social networking activities done over here. You could have your calendars over there. You could have some other things done in the over here. And I'm told that when this is going to work completely, you could, with your fingertip, you could do that and move the whatever is on that screen to the other screen. These are great ideas. I do hope that eventually they end up into the market, because these are all kind of great thoughts that we're doing. Battery life is another important factor. Independent where you are on the globe, US, China, or any other places, people bring and put a lot of value, and they are willing to pay for better battery life. There's a lot of technology that we do, not just battery technology, in order to make it happen. One of the things that enables this turbo, the great turbo that Uli talked about, is what we call the power device. In order for the CPU to be really at zero power, means that even leakage is not doing, we have a transistor that really connects or cuts the CPU completely from its power source, which means no current is flowing, which means that you allow more headroom for the other CPU to grow. There are other factors that are important. We talked about security. Last year we introduced anti-theft technology. This year we are bringing up with version 2, and we are working with additional partners, PGP and WinMagic, and we are bringing in a better enhanced data encryption. You know, it's all about protecting the device from people that steal it from you and want to get and use your data. This technology will be available next year. We continue to work with our partners, and we bring in new ones, Logic, and this one is bringing new capabilities. This allows you to do a message. So someone steals your notebook, you could have, if you're a nice kind of person like this Dadi, that asks you to please return. You know, some other people are saying, not only that the data is going to be shredded in the way Paul showed yesterday, I may shred you too. And that could be another message. Up to you, it's customized to fit your personality.